The Lord is my shepherd, I shall not want. He maketh me to lie down in green pastures. He leadeth me beside the still waters. He restoreth my soul. He leadeth me in paths of righteousness for his name's sake.
Though I walk through the valley of the shadow of death, I will fear no evil.
I will show you fear in a handful of dust.
What are the roots that clutch? What branches grow out of this stony rubbish? Son of man, you cannot say or guess, for you know only a heap of broken images, where the sun beats and the dead tree gives no shelter, the cricket no relief, and the dry stone no sound of water. Only there is shadow under this red rock. Come in under the shadow of this red rock, and I will show you something different from either your shadow at morning striding behind you, or your shadow at evening rising to meet you. I will show you fear in a handful of dust. A handful of dust.
I will fear no evil.
For thou art with me, thy rod and thy staff they comfort me. Thou preparest a table before me in the presence of mine enemies. Thou anointest my head with oil, my cup runneth over. Surely goodness and mercy shall follow me all the days of my life, and I will dwell in the house of the Lord forever. Ah, there you are. Good morning. We're still here stranded, but at least now the sun is rising. I'm hoping our vessel will be fixed very soon. But while we are still stranded, it's a good time to talk about this key I hold. This key is a kind of master key, and as we continue in our search for the rest and attempt to unlock certain doors, we will also use this master key to enrich our understanding of certain matters. As you will soon see, this master key unites many of the topics and matters of our concern, primarily the matter of lost time and history, of old world architecture, of our lost cosmology, and of the energetics of the world we live in. Our master key is complex and holds a wealth of information. We will not be discussing all it has to offer now, but rather just a small fraction of its secrets. I'm hoping what we will discuss now will prepare us well for the first door. But as we continue, we will often need to set aside further time to investigate our master key in more detail, especially in light of new information. Let's crack on. It is no great secret that the two primary luminaries above our heads, the sun and the moon, function as time-keeping instruments. Time, as we know it, comes from our sun and moon. The sun rises in the east each morning and sets in the west each evening. From its rising in the east on the previous morning, it takes 24 hours for it to rise again in the east the following morning. Everyone knows that one whole minute is 60 seconds, and that 60 minutes make an hour, and that after 24 hours each day ends and another begins. And this is represented by our clocks. Looking at a clock, it is almost impossible to state when time actually began. It could have started at any hour. The hands of the clock continue to run in a cyclical manner day after day, year after year. And we all know that there are 12 months in a year, and that every 3 months, every quarter of a year, the Earth transitions from one season to another. Life on Earth begins and renews itself in the spring. The plants on Earth capture our seasons perfectly. They grow in the spring, flourish in the summer, begin to wither and wilt in the autumn, and come winter, the trees are barren. But as we enter spring again, a new year, the plants begin to grow again. Just like the hands of the clock, life continues. It renews and keeps going in a cyclical manner. The great circle of life. All circles have 360 degrees. The diameter of every circle is proportional to the radius. The traditional clock face is a circle of 360 degrees. And in watching the moon, we see the moon takes on a similar pattern as the seasons. Each month begins with a new moon, and as the month progresses, the moon waxes or grows into a crescent, then a quarter, then a gibbous until it finally reaches a full moon. And then as the month continues into its second half, the moon begins to wane, back through a gibbous, a quarter, and a crescent until old, and then the whole process begins again. What the sun and seasons do over the course of a year, the moon does every month, like clockwork. And we live inside of this clockwork. We live inside of God's clock. But in case you hadn't noticed, this clock doesn't run as smoothly as one would expect. God made everything in perfect measure, but for some reason, he assigned 29.53059 days for the moon to complete its phases and 365.2422 days for the sun to journey from one vernal or spring equinox to another. Not only do these figures resist a tidy 360, the degrees of the circle, but they actually resist providing a convenient whole number for us. How can you have 0.2422 of a day and 0.53059 of a month? And this has proven problematic for pretty much all cultures when trying to establish their calendars. To reconcile a proper calendar in the seasonal cycle, the sun cycle must be manipulated to make that extra 0.2422 into a whole number. Adding a day every 4 years almost gets you there, but this then changes the average length of the calendar year over the course of 4 years to 365.25. If we subtract the solar year with this average calendar year, then we can see that it still overshoots the year by 0.0078 days, or 11 minutes and 14 seconds. 0.0078 days needs to be rounded up to 0.0080 or down to 0.0075. There is always a remainder. To reconcile this issue, those in charge of establishing official calendars employ intercalation. Intercalation in timekeeping is the insertion of a leap day, week, or month into some calendar years to make the calendar follow the seasons or moon phases. In the solar calendars, this is done by adding an extra day to the calendar every 4 years, and we call this a leap year. It's not spot on, but it's close enough. The lunar calendars, in their most common form, intercalate an extra day in the final month of the year 11 times over the course of 30 years. In calendar systems that use both the sun and the moon, or what is termed the lunar solar calendar, an extra 13th month or leap month is added every second or third year. It's all very complicated, and trying to dissect the way our calendars have transformed, manipulated, and misplaced time throughout history induces a swift and sharp headache. Because of the multitude of different calendars established throughout time by diverse cultures, and because ultimately our very own luminaries resist upholding tidy timekeeping behaviours, tracing time back through the calendar is an almost impossible task. If meaning, in the form of writing, is vulnerable to being lost in translation, then recorded time suffers the same susceptibility of being lost in intercalation. How to tell how much time has actually passed if the sun and moon, who inspired the very act of timekeeping in the first place, do not keep tidy time themselves? And this is what is of concern now. Why do our luminaries, primarily our sun, not behave in the way we would like them to behave in respect to time? At the end of Volume 1, the moon emerged as an unlikely but central character in our story. But it's now time to turn to another central character, that of the sun, whose importance is, in many ways, even greater. The sun is our master key. In 1999, J.L. Hilbron, professor of the history of physics and astronomy at the University of California, published a very interesting book titled The Sun in the Church. Its primary argument or point of exploration is in dissecting the notion that the Roman Catholic Church gave more financial and social support to the study of astronomy for over 6 centuries, from the recovery of ancient learning during the late Middle Ages into the Enlightenment, than any other and probably all other institutions. For prominent flat earthers, this statement would be of no surprise. Many have documented just how involved the church and Jesuits became in funding and shaping the heliocentric lie that has now come to have a firm hold over most of us since the beginning of our lives. To call Hilbrun's book a riveting read would be a lie. It's just as much a headache as some of the topics it covers, primarily that of somersault mathematics that the Jesuit-funded astronomers formulated in trying to justify the so-called science behind the heliocentric model, and the multiple commissions of the Church in trying to align Easter with the vernal or spring equinox. In Hilbrun's book, we are given an insight into the competing world of astronomers who are all trying to please the church and keep their funding going steady. The tensions we see emerge between the astronomers and the church is that between promoting heliocentrism, which directly opposes the church's desire to keep the model of the universe a geocentric one. As you know, the heliocentric model places the sun in the center of the solar system, and all the planets revolve and orbit around it. In the geocentric model, the Earth is at the center of the whole system and stationary, while the sun and planets revolve and orbit around the Earth. And the geocentric model aligns more appropriately with the Bible. The tensions between the astronomers' push for heliocentrism and the church's desire to keep the Earth at the center of it all is a carefully orchestrated historical narrative and, as per usual, not organic or innocent. Just like the politics of today, the left-wing heliocentric model and the right-wing geocentric model are, in essence, just 2 wings of the same bird, and that bird is spherical. While on the surface, the church seemed like it wanted to keep heliocentrism at bay for fear of promoting a model that is in direct opposition to what the Bible specifically states, that the sun and moon move above us and that we are stationary, what they were really doing is orchestrating a head-to-head between 2 schools of thought, geocentrism versus heliocentrism. But in both schools, our realm is an unbelievable, unscientific spherical mass. This wasn't a flat plane going up against a sphere. This was a sphere at the center coming up against a sphere flying around a gigantic sun. Alas, the narrative of geocentrism versus heliocentrism is a tired old familiar playbook of funding both sides. But the war was already won before they started their pantomime. The Earth was declared a sphere. All they needed to do now was have the scientists and mathematicians declare that their findings worked better when the sun was at the center of it all. Mission accomplished. Poor geocentrism. It got used and abused on purpose to usher in heliocentrism. Now I know what you're thinking. Great, this guy is giving us a boring history lesson on the dusty old Jesuits who probably didn't even exist in the way we are told. I know, but keep focused. What follows is so important and we cannot progress without understanding it. It will be worth it in the end. What is absolutely fascinating about Hilbrun's book is that he demonstrates that, contrary to the astropolitics of the time, the church had actually invited the sun into its arms long before heliocentrism was declared the winner. In a manner reminiscent of the Roman Empire's fusion of pagan sun worship with Christian doctrine, the Jesuits permitted and funded a handful of astronomers to set up instruments to monitor the behavior of the sun right inside some of the greatest cathedrals ever constructed. These instruments are called meridianas. They are a type of heliometer, an instrument for measuring the behavior of the sun. A meridiana is a meridian line that runs from south to north in a large dark space or building with a hole in its roof. It is primarily constructed to observe the position of the sun's noon image. Meridianas are a type of pinhole gnomon. In essence, a gnomon is a simple instrument, usually a stick in the ground, that allows the observer to track the direction and position of the shadows cast by the position of the sun in the sky. This is how sundials work, and in observing the shadows of a sundial, the observer can ascertain what time it is. Rather than a shadow, the pinhole meridiana casts a sunspot or sun image through its hole. This sunspot will fall somewhere on the meridian line, and the sunspot will travel up the meridian until the sun outside reaches the highest point in the sky. When the sun reaches its highest point in the sky, this is what we call its zenith, and when the sun is at its zenith, this is officially solar noon. As the year progresses through the seasons, the height of the sun's zenith at solar noon will change, and so will the position of the sunspot on the meridiana. Please note, I am using the term zenith here to describe the sun's highest point in the sky on any given day. I am not using it in the strict astronomical sense of the sun being 90 degrees above our head. We will get to that much later. The gnomon of Saint Sulpice in Paris is a very famous example of one of these instruments. Here we see the meridian line run across the floor of the church and up to an obelisk. They placed the obelisk here because the church was not long enough to contain the length of the path of the sunspots throughout the year. As you can see from the diagram here, in winter the sunspot will directly hit the obelisk. This is because in the northern hemisphere, during winter the sun's zenith, its highest point at solar noon, is lower in the sky. As the year progresses through to spring, the sunspot will have tracked down from the obelisk and fall on the circle near the middle. This is the marker for the spring equinox. During the spring equinox, the sun's zenith is higher at solar noon than during the winter months. And as the summer begins, the sunspot will have journeyed all the way up to the start of the meridian line here. Solar noon during summer is when the sun reaches its highest point in the sky during its annual journey. As autumn begins, the sun's highest point becomes lower in apparent height, and the sunspot makes its way back to the circle here for the autumn equinox. Now that's great. The astronomers of the Middle Ages and all the way up until the 19th century got their kicks out of creating holes in wonderful structures so they could watch the sunspot dance back and forth throughout the year. But this is not what they were really up to. They were monitoring the position of the sunspot annually and tracking the way it deviated between annual equinoxes and solstices. And maybe you're starting to think, hang on a minute, maybe the narrative is all fake, and our advanced historical ancestors, the ones who built these huge structures that acted as energy generators, also made them function as huge gnomons to trap the luminaries. It's a fancy thought, but not quite. Establishing a meridiana was no easy feat. It often required astronomers to commission drastic reflooring of these structures in order to achieve a flat level. Giovanni Cassini's method of leveling the ground is an excellent example. As Hilbrun explains, Cassini dug a ditch along the calculated course of the line, placed a wooden canal in the ditch, and filled the canal with water to provide an accurate level. The irony. The leading historical figures of astronomy had to turn to the immutable and uncurvable nature of water to achieve an accurate level, so they could track the movement of the sun. Did they know, or were they just blinded by obsessively looking at the sun? The question we need to ask, however, is why were the astronomers between the 1500s and 1800s obsessively tracking the sun's position during the equinoxes and solstices? We must now turn our attention to what the sun above us is actually doing. And it's time to talk about the obliquity of the ecliptic and the precession of the equinoxes again. Now, I broadly introduced these concepts in our examination of the moon. What I now need you to do is forget everything we explored here and in this model that I presented. We will return to it much later, but for now, forget it. to understand a crucial aspect of our master key, I need to discuss these concepts first of all, and ironically, in heliocentric model terms, and then geocentric plane model terms, or what is referred to as the flat Earth model. What I am going to try and explain now is not hard to get your head around, but it is very complex, and I will try my best. As you know, in the heliocentric model, the Earth rotates on its axis, and in addition to doing this, it orbits the Sun. One rotation on its axis is a day, roughly 24 hours, and one full orbit of the Sun is a year, or 365.2422 days. Instead of the Earth's poles being situated upright on the globe, they are displaced at an angle of roughly 23.4 degrees. This is what we call the axial tilt. The Earth rotates on this axis. In the heliocentric model, the Earth's spin and orbit are not the only movements. There are also 3 Milankovitch cycles, named after the Serbian geophysicist and astronomer who theorized them, which describe the changes in the Earth's movement and the impact it has on seasonality and locality of solar energy. Accepted scientific theory posits that the Earth's axis is slowly changing. According to this theory, there are a handful of ways it is changing, and they are happening simultaneously and slowly. We have already spoken about one of these changes, the first Milankovitch cycle, that of the change in orientation of the Earth's rotational axes, or what is called the precession of the equinoxes. Because the Earth is apparently tilted and rotates, scientists have used the analogy of a spinning top to describe this kind of axial movement. Like a spinning top, Earth doesn't just rotate in a fixed-like manner at an angle of 23.4 degrees, but traces out a cone-like trajectory very slowly over time. Because of this cone-like trajectory, the designation of our pole star directly above our North Pole, which is currently Polaris, will slowly change. Due to this precession, our pole star 5,000 years ago was Tuban, in the constellation of Draco. In 13,000 years from now, our pole star will no longer be Polaris, but will point directly at Vega in the Lyra constellations. Another way this precession is observable is in the rest of the stars above us. If our rotational axis changes to point at a different pole star, then all the positions of the stars and constellations we witness above will have also changed. And, as we discussed, one of the main demonstrations of the stars drifting from their fixed positions is the precession of the equinoxes. This drift happens very slowly, at a rate of 1 degree every 72 years, an entire constellation every 2,160 years. We can observe this by tracking the Sun's position on the equinox relative to the fixed stars beyond. The second Milankovitch cycle is much easier to grasp. It pertains to the shape of the Earth's orbital path around the Sun, or what is officially referred to as the eccentricity of the Earth's orbital cycle. The theory posits that the orbital shape of the Earth's path around the Sun fluctuates from circular to elliptical over a period of 100,000 years. As the theory states, these oscillations from circular to elliptical have a dramatic impact on glaciation, as they alter the distance of the Earth from the Sun, which therefore alters the amount of solar radiation that the Earth is exposed to. The eccentricity is affected by the gravitational attraction of the other planets, we are told, and is currently near its least elliptical, or most circular, and continues to decrease. The final Milankovitch cycle pertains to the shifting axial tilt of the Earth, or the shifting obliquity of its axes. Oblique is an adjective which means having a slanted or sloping direction, course or position, inclined, designating geometric lines or planes that are neither parallel or perpendicular. And in the heliocentric model, Earth's axis is indeed slanted. But in this model, we do not just live on a tilted and bloated spherical spinning top that is at once rotating and tracing out a cone-like trajectory, but its tilt also fluctuates. As you know, the current obliquity or tilt is 23.4 degrees, but this obliquity shifts and fluctuates between 21.1 and 24.5 degrees over a period of 41,000 years, we are told. And yet, despite all their models' complexity, we have yet to feel any motion in regard to the Earth. It is almost impossible to talk about the sun's position in the sky as if we were orbiting the sun. Try it yourselves, sit in your gardens and parks and speak about the position of the sun as if we were moving. It's morning and sunrise, which means we have spun half our cycle since yesterday evening. It feels weird to speak this way because it is unnatural. And this is because we do not feel any motion in regard to the Earth. What we actually perceive with our own eyes is the sun changing its path in the sky throughout the year. So let's try and conceptualize what this obliquity of the ecliptic looks like here on Earth. And to do this, let's head over to the equator for the equinox. The sun hasn't risen yet, so let's expand our viewpoint in anticipation. What we see here when looking out at this expanded viewpoint is what is termed the celestial sphere. It is an abstract concept and, in the spherical Earth model, surrounds a spinning ball. Now, we can divide this celestial screen in half, and this is what is known as a celestial equator. And just like the geographic equator divides the north and south of our so-called planets in half equally, the celestial equator divides the sky. We are on the geographical equator at 0 degrees latitude, so it divides our sky screen here equally. Ah, here comes the sun. Watch closely. As you can see, when positioned on the equator during the equinox, the sun reaches its true zenith, which means it is directly overhead at 90 degrees. As you can also see, the sun travels the celestial equator here perfectly. It is currently 1 PM. It will continue to traverse the celestial equator until it sets. Now, let's rewind the sun to 1 PM and see what happens as we progress through the months of the year, keeping our time fixed at 1 PM. As you can see, the sun at 1 PM changes position. It weaves between the celestial equator like a serpent. As you can see, the celestial equator remains fixed here, but there is another line carrying the sun. This line is called the ecliptic. And as you can also see, the ecliptic has both northerly and southerly limitations. The sun does not track past this line to the north and this line to the south in its annual journey. These lines mark the tropic lines of latitude, Cancer and Capricorn, which form at 23.4 degrees north and south of the equator. If the ecliptic is the annual path of the sun, then the obliquity is the northern and southern limitations of this path. There is no 23.4 degrees tilt of the Earth, but the sun deviates 23.4 degrees either side of the celestial equator during its annual journey. I understand this is quite hard to visualize, so let's spend some more time on it. To conceptualize this, we will use 4 different points in the year, the equinoxes and the solstices. Here is the path of the sun throughout the day at the equator during the spring equinox. And now the summer solstice. And the autumn equinox. And finally the winter solstice. As you can see, there are 2 forms of motion here in regard to the sun. The first is a daily motion across the sky, and the second is the yearly drifting of this daily motion to the tropic lines of latitude and back. The annual drifting of the sun to the tropic lines is the obliquity of its path. Let's now relocate to 50 degrees latitude in the northern hemisphere and see what this looks like from this location. This is the spring equinox. And now the summer solstice. the autumn equinox, and finally, again, the winter solstice. While it appears that the sun's height is changing throughout the year, it is ultimately an optical illusion. For instance, during the solstices at 50 degrees latitude north, it appears that the sun is higher in summer and lower in winter. But if we change our perspective to face southwest and combine the two images, you can see the sun is not increasing and decreasing in height during its annual journey, but its location relative to the celestial equator changes. Therefore, it looks higher in the summer in the northern hemisphere as it is journeying the Tropic of Cancer, and therefore closer to those living in this location. And it looks lower in the winter as it journeys the Tropic of Capricorn as it is further away. There is a very profound paradox surrounding this, and we will explore it much later in our journey. But play around with vanishing point vectors and it may become apparent. In all its simplicity, the obliquity of the ecliptic is nothing more than the geographic limitations of the sun's annual pathway. And these limitations are located at 23.4 degrees north and south of the equator. And as you saw in this demonstration, the sun's annual journey across its ecliptic pathway forms like a serpent sine wave or energized helix. You can also see that at some point the ecliptic line traverses the celestial equator. This occurs twice a year, and this is what we call the equinoxes. It is the meeting of two lines. And you can see here on the equinox, when the sun is at solar noon, that the cross these lines form visually represents the obliquity of the sun's path. There is a 23.4 degree difference between both the ecliptic pathway of the sun and the celestial equator. This is the obliquity of the ecliptic, or what the scientists have termed E. And it's because of the obliquity, because the sun drifts between the northern and southern tropics annually, that we have changing seasons. The heliocentric model posits that the obliquity of the sun's apparent pathway in the sky above us is due to the Earth's axial tilt. In this model, the seasons occur because of the tilt of the Earth. For instance, as the Earth journeys away from the spring equinox, the northern hemisphere tips more towards the sun due to the axial tilt. This means it is summer in the northern hemisphere. As the Earth rotates, the angle of its tilt changes, and therefore the seasons begin to change because of the variations in solar light and radiation hitting the northern and southern hemispheres. In the flat Earth model, it is the sun that is moving above us. This model attempts to capture the sun's path and its obliquity through the concept of a spiral coil. From the equator, the sun spirals inward until it reaches the Tropic of Cancer north at 23.4 degrees latitude. It then spirals outward back to the equator for the equinox, and then keeps going until reaching the Tropic of Capricorn south at 23.4 degrees latitude. And although this model's conception of the sun's annual pathway is not entirely accurate, it is accurate in its argument that it is the sun above us that is moving and that its annual pathway deviates from the equator. To summarize then, the annual path of the sun does not continually traverse the celestial equator, but deviates north and south on its ecliptic line, reaching a maximum of 23.4 degrees latitude. And the angle, or degrees, between the ecliptic pathway and the celestial equator is what is termed as the obliquity of the ecliptic, or E. And in addition to the seasons, one of the key ways this obliquity and the second Milankovitch cycle of eccentricity affects our lives here on Earth is in the difference between the hands of the man-made clock and the actual behaviour of the sun clock above us. Hilbrand's research demonstrates that both the Church and the astronomers from the 16th century onwards were obsessed with monitoring the annual path of the sun and tracking any deviations that occurred each year. and they found that meridianas were a good way to do this. But the meridiana and the vast amount of sundials and other heliometers that were appearing in excess throughout European cities and towns up until the 19th century also provided a service to the locals. They were able to congregate around a sundial around local noon to reset their clocks. The locals could watch the shadow of the sundial approach noon and wind their clocks to make sure they were running on accurate time. But there was a problem, for you see, before the establishment of time zones and standardized time, noon happened at different times within the same country and even within the same city. As well as forming a reliance on town sundials, the locals also relied on church bells to chime at the right moment to ascertain the time and wind their clocks. But for those living in a city such as Rome, according to Hilbron, it might take 20 minutes or more for all the churches in the city to ring in the same hour. The disparity in sounding the hours among church clocks throughout Europe, he continues, was notorious. And it was up to the individual to ensure they kept running on true time. As one Jesuit teaching manual from the time preached, the clocks almost never agree. You must overcome this defect by your diligence. And this disparity between the man-made clock and the actual sun clock above us presents itself because of the obliquity of the ecliptic and the sun's eccentricity. The reason for this is because our clocks make the intervals between each successive day equal to 24 hours. If it is noon on a Tuesday, then you can guarantee that in 24 hours time, your wristwatch will tell you it's noon on a Wednesday. Our clocks are regular and standardized. If you look at your wristwatch and see that it is 9 PM on a Friday, then you can feel reassured that 24 hours later, the hands will be striking 9 PM on Saturday. But the sun above us does not act in this regular and standardized manner. For instance, solar noon on the 7th of April occurred at 12:56 PM. But a month later on the 7th of May, it occurred 4 minutes earlier at 12:52 PM. If the sun only journeyed the celestial equator, like it does on the equinoxes, then the sun and the clock would align and solar noon would occur every day at the same time. But because of its obliquity, it slowly starts to fall out of sync with the man-made clock in its annual journey. And, as the locals soon found out, the amount of discrepancy between their clocks and the actual time told by the shadows cast from the sun above changed from day to day. The fault was not only in the clock. No matter how accurate its movement, a clock made to tell equal hours throughout the year must disagree with the sun most of the time. And that was fine, as the locals ensured they kept their clocks aligned to the sun. But then another problem arose. As the locals became good at congregating around town sundials and making sure their watch time and the sun time aligned, they would notice that during 2 periods of the year, the shadows of the sundial would move faster and slower than the hands of their clocks. This is the effect of the second Milankovitch cycle, the sun's eccentricity. Because the sun's annual pathway between its tropic limitations is not a true circle, but is slightly elliptical, the sun moves a maximum of 14 minutes slower in February than a man-made clock, and moves at a maximum of around 16 minutes faster than the clock during November. Remember, on the 7th of April, solar noon occurred at 12:56 PM. While on the 7th of November, it occurred at 11:40 AM, a whole 16 minutes faster, including the hour for daylight saving. And that's because the sun's annual pathway between its tropic limitations is not a true circle, but is slightly elliptical, and therefore doesn't move with one regular speed, but speeds up and slows down during 2 times throughout the year. And if you combine both the effects of the obliquity and the eccentricity, you end up with a graph looking like this. The horizontal line here represents our man-made standardized clocks that bring in each new day with 24-hour-long intervals between successive days. But the positive and negative crests of the sine wave here represents the way the sun clock above us deviates from the man-made clock throughout the year. The positive is when the sun is faster than the clock, and the negative is when it is slower than the clock. And the difference between the sun's irregular behaviour and the clock's regular tidy ticking is what is called the equation of time. If you were to set up a camera in the same spot and take a photograph of the sun throughout the year, ensuring that you took the photograph at the exact same clock time each day, you'd witness something very, very special. It's called the analemma. It is one of the most magnificent and mind-blowing phenomena related to the luminaries, and it captures the influence of the obliquity and the eccentricity of the sun's path perfectly. The shape of the analemma, the figure of 8 with uneven lobes, or some might even say the figure of a fish, is a celestial embodiment of the equation of time. If there were no obliquity and eccentricity, and the sun ran as our man-made clocks run, if each interval between successive solar noons was in fact 24 hours, then there would be no analemma throughout the year. The sun would appear at the same point in the sky at the same time of day throughout the year. The analemma would be a dot. If the sun's obliquity, its northern and southern drifting, was still present, but the eccentricity of the path was circular and not elliptical like it is today, then the analemma would be a symmetrical figure of 8, and its southern and northern lobes would be of equal size. And really, the easiest way to demonstrate just how much the obliquity of the ecliptic, the 23.4 degrees drifting, of the sun in its annual path to the north and the south affects our lives on Earth is to imagine if it didn't exist at all. Let's also imagine that the eccentricity was always circular. If we reduce the obliquity to 0 degrees so that the sun's path ran completely perpendicular to the celestial equator throughout the year, then not only would the sun keep tidy time and align with our clocks, but there would be no seasonal fluctuations, and day and night would be equal length, day in, day out, year in, year out. And John Milton, in his epic poem Paradise Lost, theorized that the sun's path in the pre-fallen Edenic world had no obliquity. Some say he bid his angels turn askance, the poles of the earth twice 10 degrees and more, from the sun's axle, they with labour pushed oblique the centric globe. But what would happen if the obliquity increased to 90 degrees? The limitations of the sun's path, the tropic lines of latitude, would then be relocated to here, and there would be a dramatic effect on seasonality. A lot of ice would melt, wouldn't you say? And here is where it gets very interesting. As Hilbrun's The Sun in the Church explores, the Jesuits and astronomers were not just flexing their mathematical prowess in trying to determine whether the Earth orbited the Sun or vice versa. They were obsessively checking whether the obliquity was shifting. As early as 2000 BC, different cultures were measuring the obliquity, we are told. And it was widely believed during the Middle Ages that the obliquity oscillated around a mean value. What does this mean? Since the Middle Ages, the 23.4 degrees has been, give or take, the accepted mean average. And Milankovitch later hypothesized that Earth's axial tilt varies over a 41,000 year period from 22.1 to 24.5 degrees. And like we just briefly demonstrated, if the angle of obliquity were to change, then both tropics would move in tandem. As you know, there are 5 prominent circles of latitude. We have the Arctic and Antarctic circles, the Tropic of Cancer and Capricorn, and in the middle we have the equator. These lines of latitude are what is known as parallels. They are bound by one another. If one were to move, then another line of latitude would also move in parallel. In the flat Earth model, this would mean these concentric spiral rings would begin to shift in parallel, either moving closer together or further apart. If the obliquity changed to 10 degrees, then they would shift closer to the equator. If the shift went to 60 degrees, then they would move further apart. In the less popular and underrated rectangular models of flat Earth, the same thing would happen. The tropic limitations would shift closer or further from the equator, and the Arctic and Antarctic lines would also be relocated. And you might want to ask, why did Milankovitch only hypothesize a shift in obliquity between 22.1 and 24.5 degrees? A shift of 1.1 degrees from 23.4 to 24.5 and 1.3 degrees from 23.4 to 22.1 seems, after all, quite a small fluctuation in the grand scheme of things. Why wouldn't the obliquity ever go back to 0 degrees or all the way to 90 degrees in their model? Before we theorize, let's quickly examine what Wikipedia tells us about this shift. As they state, the Tropic of Cancer is currently shifting southward at a rate of almost half an arcsecond of latitude, or 15 meters per year. As a result, approximately and on average, the tropical circles are drifting towards the equator and the polar circles toward the poles by 15 meters per year. If the tropics are currently shifting at almost half an arcsecond of latitude each year, how long would this take to see some significant change in their location? Just like how clocks divide the hour into minutes and the minutes into seconds, 1 degree of latitude can be broken down into arc minutes and arc seconds. 60 arc seconds make an arc minute, and 60 arc minutes make 1 degree. Just as there are 3,600 seconds in an hour, there are also 3,600 arc seconds in a degree. If the current rate of shift in obliquity is 1 arc second every 2 years, then we can times 2 by 3,600 and we get a rough, rounded up estimation that it would take 7,200 years for the obliquity to move 1 whole degree. Wow, that is a very long time. It is 100 times slower than the precession of the equinoxes, in which the fixed stars drift from their fixed positions by 1 degree every 72 years. This rate of half an arc second is also consistent with Hilbrand's analysis of the data collected by astronomers between 1700 to 1800. And if Milankovitch is correct, then after 7,200 years, the obliquity will have changed from 23.4 degrees to 22.4 degrees, and will continue to decrease for a few more centuries before turning and beginning to shift back the other way. And now I know what you want to say. They are liars. How do we know the obliquity fluctuates between 22.1 and 24.5 degrees? It could keep decreasing beyond 22.1 degrees. And they've also lied about our history. So how can we trust the alleged data records regarding this shift? The obliquity could have been doing anything in the past. And I agree, they are tremendous liars. The problem with the luminaries, the sky clock above us, is that the drifts and shifts happen very slowly, and we only live an average lifespan of 70 or so years. The motions above us could speed up, slow down, change course, stop altogether, and we wouldn't know about it, especially if the historical data is fraudulent. As Hilbrand states in his introduction, and in his 66th citation, among the old meanings of mathematizer, to mathematize was to cast a spell. There will be time to let our imaginations run away with themselves, but before that, let me introduce you to the work of George Dodwell. In 1934, Australian astronomer George Dodwell turned his attention to the obliquity of the ecliptic. His investigative research spanned many years and was not published in his lifetime. In his study of various ancient astronomical and solar observatories and the data the ancients collected on the shift in obliquity, Dodwell discovered that the historical data, which dated beyond 2000 BC, deviated from the contemporary average rate of half an arc second every year, quite significantly. Dodwell collected all historical measurements of the shift in obliquity, scrutinized them, and then presented them in this graph, titled the Curve of Obliquity. The first thing that is fascinating about Dodwell's graph and findings is that he demonstrates that the obliquity was 25.1 degrees in 2000 BC, which is already beyond Milankovich's threshold of 24.5 degrees. Dodwell also demonstrated that as the obliquity declined over the centuries towards the current 23.4 degrees, it formed a very recognizable pattern. This pattern here, Dodwell argues, is evidence of a curve of recovery. What does this mean? Well, as the obliquity went from 25.1 degrees from 2000 BC to the current 23.4 degrees, it underwent a pattern of oscillation. This is represented here by this sine wave. As the centuries unfolded, the obliquity would decrease slightly and then increase back. It would oscillate. But, and this is crucial, if you look closely, you can see that each successive wave here decreases in size as the centuries continue. These maximum and minimum fluctuations repeat 3 times, but each time they decrease. This pattern, Dodwell states, is what is known as a curve of recovery. And it means that while the obliquity has been decreasing in degrees since beyond 2000 BC, its fluctuations here show that it is actually settling. Dodwell argues this proves a movement of recovery, from a great disturbance back here to a slow fluctuating decrease until reaching an equilibrium around the 19th century here. Dodwell's research implies that, unlike the accepted Milankovitch theory, the shift in obliquity could actually be a stabilization effect that is occurring in the aftermath of a much greater disturbance. Dodwell concluded that this great disturbance was the Great Flood. And that's very interesting. We have John Milton on one hand, saying that after the fall of man, God asked his angels to turn the sun's axial oblique, and we have Dodwell on the other, demonstrating that the obliquity shifts are actually an attempt to recover in the aftermath of the Great Flood. Could this be why our sun appears out of sync with time? Because a great historical event changed its course? And if Dodwell is correct, then that would mean that this event took place sometime before 2000 BC, or over 4,000 years ago. But what if our timeline is incorrect? What if they have added 1,000 years here or there? This graph would certainly compress if so. We will not be solving the problem of shift in obliquity. We are, after all, mere mortals with short lifespans. But these so-called ancient solar observatories do warrant some further investigation. Are they genuine, or just repurposed sites like the cathedral heliometers? I want to show you something now that's quite remarkable. Look. Whoa. As you just saw, many of the so-called ancient monuments of the past still, to this day, perfectly align with the annual equinox and other key dates. And before you get too excited and start claiming that those of the old world were true masters of the universe and built these structures to align perfectly with the equinox, let's look a little closer at this. The work of Dr. Jayasri Saranathan brought something to my attention that I had not really considered before. The Gregorian calendar was established 439 years ago, in 1582, around the same time the astronomers started making holes in cathedrals. And one of the primary purposes for its creation was to stop the calendar drifting from the equinox date of March 21st. As if things were not confusing enough already, the solar or tropical year is determined by the length of time it takes for the sun to journey from one spring equinox to the following spring equinox. And this amounts to 365.2422 days. But a sidereal year is the time it takes for the sun to return to the same position with respect to the fixed stars beyond. The solar year is 20 minutes shorter than the sidereal year, and they tell us this is because of the precession of the equinoxes. Remember, in this theory, the Earth is tracing out a cone-like trajectory, and because of this, the intersecting point here between the celestial equator and the ecliptic, or what we call the equinox, is supposed to be moving backward or westward at a rate of 1 degree every 72 years. If the sun falls behind by 20 minutes a year, this means it falls behind an entire 24 hours, a whole day, every 72 years. As Saranathan states, it is understood that there is no change in the tropical equinoctial date in the Gregorian calendar. The spring equinox always occurs on the 21st of March, or the 20th to 21st of March. As per precession theory, this date must have drifted by 5.9 days since the inception of the Gregorian calendar, 430 years ago, but it is found to be occurring on the same date. These structures should not align with the March 21st equinox date of today if they were built hundreds, if not thousands of years ago, to align with the equinox date of their time. The brainwashed will shout that this is because the Gregorian calendar is constructed to ensure the March equinox pretty much remains the same, give or take a day or two. But the only adjustment in the calendar is for the leap year. You cannot tell me that these structures align exactly on this date because the calendar computes one leap year every 4 years. If this Mayan pyramid was built over 1,000 years ago, then the calendar date of the equinox should have shifted by 13.8 days. The serpent shadow should not appear in March. If Angkor Wat was constructed 900 years ago, then the date should have shifted by 12.5 days. And what about structures like the Temple of Abu Simbel? Every year, on the 22nd of February and October, this chamber is illuminated by the sun to mark King Ramesses' birthday and coronation. These dates are not on the equinox, and yet they still align today, with a structure that has allegedly held this alignment for thousands of years. And we see the same thing here with Newgrange, a structure that is allegedly 5,000 years old, but still aligns with the winter solstice date year after year. This date should have drifted by 69 days. If Stonehenge was constructed over 4,000 years ago, then the calendar date of the summer solstice should have shifted by 55 days, which means it should occur in April. To think these alignments are all the work of the Gregorian calendar is absurd. No, the only reasonable explanation for this is that the Earth and Sun are bound in their alignment and that there is a complete absence of precession or movement in regard to the Earth. And really, it's marvellous when our two key opponents, that is, his story and heliocentrism, unashamedly enter a stalemate. Mr. Tyson and Mr. Cox want you to believe that not only is our realm a spherical mass that orbits a gigantic sun, which squats stationary millions of miles away, But they also want you to believe that this spherical mass is tilted on its axis, wobbling and precessing. All the while, not one of our senses perceive this motion, and both the ancient structures of the past and the Gregorian calendar prove that there is no axial precession. They prove that the Earth and Sun are bound in their alignment, and it is the Sun that is moving relative to the fixed stars beyond. And then you have the pseudo-archaeologists and pseudo-historians such as John Major Jenkins and Graham Hancock trying to do the damage control. If the Great Pyramid and Angkor Wat have astronomical alignments, then, according to Hancock, this means that they must have been built over 20,000 years ago to align with the precession of the Earth. John Major Jenkins declared that some of these structures and their astronomical alignments mean that they were built as a precessional clock with its alarm set for the 21st century. Yeah, right, it's one of the most ridiculous statements ever made. The Earth is not moving, it is the luminaries that are moving. And there we have it. Are the astronomers lying, or are the historians lying? They have a stalemate, but we have a checkmate. And here is the problem. How genuine are structures like Stonehenge, the Great Pyramid, Angkor Wat, the Temple of Abu Simbel? We do, after all, have proof of them moving and messing with structures like Stonehenge and Abu Simbel. Do you know when Angkor Wat was allegedly rediscovered by the West? In 1860. Why did it need rediscovering? Did you know that Angkor Wat was perfectly replicated for the colonial World's Fairs in Marseille and Paris in the early 20th century, just 60 years after its rediscovery? Just how old are some of these structures, especially the sites that align with the sun? Did you know that many obelisks also functioned as huge gnomons? Even the Great Pyramids themselves, Dodwell writes, were, for practical purposes, essentially gnomons on a gigantic scale. Do you know where they got the inspiration to use the obelisk in St. Sulpice? Ancient Rome. As the legend goes, Augustus erected an obelisk that he stole from Egypt and used it as a huge sundial to express his power and glory. Nothing remains of Augustus's huge sundial today except the obelisk, now moved from its original location. Do you know how many of these structures have been moved, altered, broken, redesigned and repurposed? Have you ever done a tour of the cathedrals in Europe and counted all the instruments they contain that record the movement of the sun? Why and for what? Why do so many cities around the world feature giant obelisks? And I know what you're going to say. It's because those of the old world were the true masters of the universe and built all of their structures in accordance with the luminaries. Again, it's a fancy thought, but no. Many of us have fallen into the trap of underestimating repurposement. Let's briefly recap and see what we have so far. 1. Our sun does not keep tidy time like our clocks, and this is primarily due to the obliquity of its annual path. 2. There was a huge, organised and commissioned effort funded by the Jesuits in the Middle Ages and up until the 19th century to track the movement of the sun and its change in obliquity, and this resulted in the repurposement of many structures. The Gregorian calendar was also established during this time period. 3. No aspect of the heliocentric and Milankovitch theoretical models can appropriately explain why the sun has an obliquity of 23.4 degrees. 4. Dodwell's analysis shows that the sun's shift in obliquity demonstrates a pattern of recovery from a much larger disturbance in the past. 5. Many of the so-called ancient structures in our history align with the luminaries, especially the sun. The authenticity of many of these structures is questionable. Now, let's ask a theoretical question. Is it possible that a great disturbance occurred in the past that affected our sun and in turn caused the disappearance of the old world, and those that followed repurposed these structures to ascertain the status of the sun and reconceptualize a new model of the Earth and universe? And now let's take this even further and ask more of a sweeping theoretical question. What if, like with all world nations, tensions emerged in the old world and there was a war, and that war culminated in a great disturbance that altered the behaviour of the sun, and as a consequence caused a lot of people to vanish? Did a certain faction of people conquer the old world and subsequently come to worship the sun because of this? I sound like a conspiracy theorist, and maybe all we can do is speculate. But have you ever really given concentrated focus to the undeniable prevalence of sun worship throughout our world? And that number, 666, if we subtract 23.4 degrees from 90 degrees, we get 66.6 degrees. Could the origin of that number come from the sun? Did the sun's annual path and its limitations historically extend to 90 degrees? Surely not. The seasons would be very dramatic. But what if the realm is bigger than we know? What are poles anyway? And who worships the sun? What is light? Did all cultures that came before worship the light, or did something else happen? What does it mean to go from dark to light? Why did Joshua ask God to make the sun stand still? And who writes history? Who rewrites, repurposes, appropriates, and destroys history? Those that triumph. Do not underestimate repurposement. And here is one final question, and this question is going to become one of our investigative tools from now on. Our entire lives have been shaped by a false, heliocentric cosmology, and our methods of keeping time are fundamentally heliocentric. But what if our entire historical narrative has been rewritten and reshaped as a heliocentric one? And what lies beneath it? Who actually built these clocks? The same people who built the cathedrals, or the same people who repurposed them in honor of the sun? Start looking closer in your day-to-day. Look a lot closer. We have only just begun to examine our master key, but as you can see, it gets the mind ticking. And it's also given us a time frame to work with. The cathedral heliometers and the Gregorian calendar were established in the 16th century. This period has been termed the Renaissance. Do you know what that word means? It means rebirth, to reappear, to rise again, to be born again. Who or what rose again? I think it's time we left this dreaded place and journeyed on in search of the next key. I know the man who holds it and exactly where to find him. He's been waiting for us, but I fear we are too late. We will have to attempt to go to Siberia later. We have missed our window of opportunity. We have to open this door now because we cannot continue unless we start to grasp the overwhelming complexity of how much they have changed throughout the last 400 to 500 years. Many have sadly underestimated just how enormously our history and the monuments and structures of the past have been repurposed. Come on, wait, what? You have a question. These ancient structures still align with the equinox date of March 21st, and this proves that the Earth and Sun are bound in their alignment, right? Yes, that's correct. Then how can the magnetic pole be moving and taking the Sun with it like you said in this model? That's the spirit. An excellent question in light of new information, and the first instance of a trend that will definitely continue as we progress. You'll notice that as we start to open doors, we will also open many cans of worms. But you're just a little too early. Something is fundamentally missing here. There is a thing that nothing is, and yet it has a name. Have you ever really considered the word noon? It is one of the most beautiful words in the English language. It is a palindrome. It reads the same both ways. But have you ever noticed that it visually represents the sun's daily path? The two ends look like doors, the east and the west in which the sun arrives and departs, and the O's, the sun's form as it journeys its path. When we set out so long ago to ask what on earth happened, The brilliant light of awakening was like a sunrise heading towards its zenith. Perhaps our journey has even felt like a kind of enlightenment. But Icarus flew too close to the sun and was cast back down. And it's about that time. That's where we are heading. We have culminated, and a steady descent into the dark is coming. It'll be clear what I mean by this as we continue. And please forgive me, I had to introduce a story this way to open your eyes, and I couldn't have done it any other way. Up until now, I have presented the general consensus on both our hidden history and hidden cosmology, but you're awake now, and as we continue in our quest for the keys, a lot of what we've covered will need to be looked at very critically. And it's better this way. It's better to debunk myself than stomp on others. And although it's not time, you're right. Our master key paves the way for us to critically look at the path of the sun above us. The sun is not moving in this circular manner as the flat earth model depicts. All cosmologies, whether spherical, concave, flat azimuthal, or flat Mercator fail, and the dynamic between the model, the map, and the sun is the problem. We will be looking closer at all cosmologies much later. And don't worry, our two central characters will meet at some point, for what would our journey be without the appearance of the corona? And we need to make a deal right now. If you are to continue on this journey, and we start uncovering things that do not hold up to critical investigation or no longer work, then we must let them go, no matter how much we have grown attached to them. Otherwise we will be carrying baggage, and we cannot afford another crash, so let's shake on it. Excellent. Ah, and look at that, our vessel is fixed. We can finally journey onward. Let's get going. It's time to get this door wide open, and we are already late for a very important date. Let's just hope our man is still there waiting to give us the key.